Assalamualaikum warahmatullahi wabarakatuh. How are you guys? Okay, I will introduce myself. My name is Erin Dimyati. I'm from the chemistry majority of the Science and Technology Faculty of the State Islamic University of Raden, Fatah, Palembang, and I will explain about this. Have a good time to watching.
Some properties of liquid and solid. The first, condensed phases. Solid and liquids are referred to collectively as condensed phases. This name emphasizes the high density of the liquid or solid as compared with the low density of gas. This difference in density is one of the most striking differences between gases and solid or liquids. The mass of air in a room of moderate size will not exceed 200 pounds. The mass of liquid required to fill the same room will be some hundreds of tons. Conversely, the volume per mole is very large for gases and very small for liquid and solids. At STP, a gas occupies 22,400 centimeter cubic per mole, while the majority of liquid and solid occupy between 10 and 100 centimeter cubic per mole. Under this condition, the molar volume of a gas is 500 to 1,000 times larger than that of a liquid or solid. The ratio of the gas volume to liquid volume is 1,000, then that the ratio of the distance between the molecules in the gas to that between those in the liquid is the cube root of the volume ratio, that is 10. Then the molecules of the gas are 10 times farther apart on the average that are those of the liquid. The distance between molecules in the liquid is roughly equal to the molecule's diameter. Hence, in the gas, the molecules are separated by a distance which is, on the average, 10 times their diameter. This large spacing in the gas compared with that in the liquids result in the characteristic properties of the gas and the contracts of the properties with those of the liquid. This comes about simple because of short range nature of the intermolecular force. Then the van der Waals force. Effect of these forces decreases very sharply with increases in the distance between the molecules and falls to an almost negligible value at distance of 4 to 5 times the molecular's diameter. If we measure the force by the magnitude of the term in the van der Waals equation, the n increases in volume by a factor of 1,000 in going from liquid to gas decreases the term by a factor of 10. Conversely, in the liquid, The effect of the van der Waals force is a million times larger than is in the gas. Coefficient of thermal expansion and compressibility. The depends of the volume of a solid or liquid on temperature at constant pressure can be expressed by the equation number 1. You can see where T is the Celsius temperature, V0 is the volume of the solid or liquid at 0 degrees Celsius, and delta is the coefficient of thermal expansion. Equation 1 is formally the same equation 2, which relates the volume of the gas to the temperature. The important difference between the two equations is that the value of delta is approximately the same for all gases. While the two equations is that the value of x is approximately the same for all gas, while each liquid or solid has its own particular value of delta. Any particular substance has different value of delta in the solid and in the liquid state. The value of a delta is constant over limited ranges of temperature. If the data are to be represented with pressure over a wide range of temperature, it is necessary to use an equation with higher power of T B equal V0 1 plus delta T plus P equal V0 1 plus AT plus BT 2 plus ATG, where A and B are constant for gases and solid. Delta is always positive, while for liquids delta is usually positive. There are a few liquids for which is negative over small range of temperature. For example, between 0 and 4 degrees Celsius, water has a negative value of delta. In this small temperature interval, the specific volume of water decreases as the temperature increases. In equation 1, V0 is function of pressure. Experimentally, it is found that the ratio between volume and pressure is given by, you can see equation number 3, yes, where V0 is the volume at 0 degrees Celsius under atmosphere pressure. V is the pressure in atmosphere, and K is the coefficient of compressibility, which is a constant for a particular substance over a fairly wide range of pressure. The value of K is different for each substance, and for the solid and liquid states of the same substance. It is shown in selection that the necessary condition for mechanical stability of substance is that K must be positive. According to equation number 3, the volume of a solid or liquid discretes linear with pressure. This behavior is in sharp contrast to the behavior of gases in which the volume is inversely proportional to the pressure. Furthermore, the volumes of K for liquid and solids are extremely small, being of the order of 10 squared is mean 5 being of the order of 10 squared is mean 6 to 10 squared is mean 5 atm squared mean 1. If we take K equal 10 squared mean 5, then for a pressure of 2 atmospheres, the volume of the condensed phase is by equation number 3, V equals V0, 1 means 10 squared mean 5 times 1. The decreases in volume in going from 1 atm to 2 atm pressure is 0.001%. If a gas were subject to the same change in pressure, the volume would be halved because moderate change in pressure produce only very tiny change in the volume of liquid and solids. It is often convenient to consider them to be incompressible. K equals 0 in the first approximation. Combining equation number 1 and number 3 by eliminating V0 yields an equation of state for the constant phase. You can see equation for number 4. To use the equation for any particular solid or liquid, the values of delta and K for the substance must be known. Values of delta and K for a few common solids and liquid are given in table. Okay, the last heads of fission, vaporization, sublimation. The operation or releases of heat without any accompanying temperature change is characteristic of change in the state of aggregation of substance. The quantity of heat absorbed in the transformation of solid to liquids is the head of fission. The quantity of heat absorbed in the transformation of solid to liquid is the head of fission. Replay. The equation of heat absorbed in the transformation of liquid to vapor is the heat of vaporization. The direct transformation of solid to vapor is called sublimation. The quantity of heat absorbed is the heat of sublimation, which is equal to the sum of the heats of fusion and vaporization.
Okay guys, thank you for watching. Don't forget to like, comment, share, and subscribe. It is important for me. And thank you for watching. Wassalamualaikum warahmatullahi wabarakatuh.